This is the Mechanics Homework Booklet, question 29. The diagram shows a skier being pulled by a rope up a hill of incline 12 degrees at a steady speed. The mass of the skier is 85 kilograms and two of the forces acting on the skier are shown. So looking at the diagram, you can see tension in the rope pulling the skier up the slope, and you can see the normal reaction to the skier's weight, which acts perpendicular to the slope. First, you are asked to mark with arrows and label two more forces acting on the skier. One of the marks is allocated to the answer of the weight. So the weight of the skier should be shown acting as an arrow from the skier vertically down. You might call this the force of gravity, but you would not get a mark for the word gravity on its own. The second mark is allocated to either air resistance or a friction force. Either of these forces would be marked going down the slope parallel to it from the skier as shown. Next, you are asked to find the magnitude of the normal reaction on the skier. So the normal reaction was marked in the diagram, and you need to realise that this will be equal to the component of the weight perpendicular to the slope. So we want to resolve this force here into this direction here, perpendicular to the slope. So that will be the weight, mg, times cos of 12. So substitute in the values. 85 was given in the question, and the angle of 12 leads you to an answer of 816 newtons. That could be recorded to 820 newtons to two significant figures. Finally, you are asked to explain why the resultant force on the skier must be zero. To answer this question, it's good to look back to the wording at the beginning of the question. You were told that the skier is being pulled at a steady speed. So as a result, that means steady speed is constant velocity or constant speed, and that would imply that the resultant force must be zero. Or alternatively, you might say that the skier experiences zero acceleration.